talking about shared border in Cisco Nexus Dashboard Fabric Controller. To better understand the benefits of a shared border, first we'll assume you have a single physical data center with hundreds of thousands switches. Having all those switches in a single site could cause issues within the fabric, where one or two failed switches could affect the stability of the network. So one solution is to the problem divide the physical data center into separate sites. Okay, as you can see, we have site 1 to site n in blue clouds, and it is still a single physical location, but we split that a single physical data center into separate sites will let me to make my network as resilient as possible, right? So when I separated the center into separate sites correctly, I have to take down one site for maintenance, application, and services available, and in remaining sites are unaffected. So we're talking about here is the east-west traffic, right? Using the list topology, we are gonna assume there's an application inside one, and there's another application inside N, and those are applications who want to communicate to each other. This can accomplished by just connecting two sites using the multi-site. We have done that. We have to make the site 1 a DC1, DC2, and using a super route spine route server in EVPN for the multi-site connections, right? So in this multi-site, we have done that to overlay the clouds in this MSO multi-site overlay. And what about the north-south traffic? The site application inside one and side N now needs to connect to the internet or the other sites, external site. We're showing here is the green, the external connectivity cloud in this example. So typically, this can be accomplished just using a set of border devices or border gateways that allow me to connect my individual site to internet or external sites. So it's the green border boxes in this example, right? However, so additional some consideration will come and when configuring north-south traffic from individual sites to internet or external. So this will where we position the firewall or load balancers, how to set up the common ingress and egress points for this traffic between the site or internet and those questions. So one solution is with redundancy between the sites also will provide a cost-effective way to connect each site to internet or external sites is by using a shared services through a shared border. So the border technology is commonly used in latest developments. Okay, so you would build hierarchical multi-clouds, and you would want to have a common panel for the north to south traffic. So this will is detrimental, uh, is determine mistake behavior rather than having a single point failure or underestimated behavior between the sites. For example, I have the site 2 border leave to the internet, or I have site 1 to the internet, their own internet. We can all using the shared border with redundancy two shared borders. Okay. So this blue sites 1 and site n uh, are in the lower part of the example here will be shared this shared border. So for example, here we have two shared border in shared border box. Here we have shared border fabric handle any services that require we have can put in the firewall inspection, load balance, L4 to L7 services, or we have light connectivity from the data center to cloud and so on. This allows me to share these services through these devices, and will provide means to cross border from inter-site, like the site 1 to site N fabrics to internet or external connectivity. That's right. This is what we call shared border. Okay. Before we do it, I show you the current topology here. We have site 1 and site 2, DC1, DC2. They are communicating with each other with the super spine route server. And this is how the current MST multi-site domain looks like. Okay. Over the top of the ISN network, the super spine route server, we're going to create a shared border fabric and add a shared border switches there. So let's go over to the LAN fabrics. We have MSD, it has DC1, DC2, ISN. Okay, we're gonna create our fabric. With fabric, we're gonna call a shared dash border, and pick a fabric type is data center, VXLAN VPN. Previously we called easy fabric. Select it. Okay. And we're gonna change a little bit to the mask 31, and replication is would be RP251. We're gonna to go to the down here. We should have a green field. It's under advanced. Yeah, green field cleanup. We're saying enable, and go back to resources, change the IPs. Go down. We wanted to add light because we wanted to deploy a external fabric. This is my external fabric we wanted to use. We're using the VF back to back, and I wanted to auto deploy for the peer. Okay, check this. Scroll down here to VF, makes 24 less. All right, save this to create the fabric. Out to the ASN 300. Save this. Okay. And you will find the shared border fabrics not part MSD. Multi-site domain will add it. My switch. Uncheck preserved configuration. Now check shared border 1. Add. Okay, now my switch is added and called shared border. For next, we wanted to assign a role. Click my switch, set a role to be border. We'll find a border, select it. All right. So next, we'll recalculate boot actions, recalculate and deploy. Deploy all. I'm seeing my switch, assign a role to border, close this, go to MSD, go to child fabric. We're going to move it to my child fabric under my multi-site domain. Okay. Now it's added AS number 300. One tricky part is we have to create a policy in MSD. Let's add a policy. We'll find is my share border. One, switch, next. The next dashboard fabric controller has a policy defined for share border. It calls share border state. Choose this, select. And it doesn't ask you much, then click save. For next step, go through the boot action under MSD. Remember, this step is important. We'll do one calculation and deployment. So this will deploy all the super spine and share border. You'll find share border will be configured. And of course, if you previously do not have super border configuration for this setup, you will see the commands to be executed in super spine or 2. Okay, now it's complete. Close. Okay, and the tricky part is only in MSD. Go to share border and do a calculate. There you go. We're seeing certain lines have loopbacks. A lot of people will forget this step. We need a loopbacks to build the EVPN, eBGP peer neighborship with SuperSpine. Okay, now we want to do one more step is go back to MSD, go to VIF, and check all VIFs. We do multi-attach, want to attach to of the switch. See the lines pending on on share border. Most of the VLANs, VIFs. Okay, and close this or deploy all. All right, close this. Wait to void. Okay, networks. Check all the networks. Multi-attach. One attach to share borders. This step will to attach network to share borders. Click next. We don't have to assign the interface. That's fine. 57 lines, mostly for the networks. Close that. Deploy all. All right, close that. Close. Go to topology. Check configurations. What we have is a share border. Log on to my share border, show BGP session. Log on to SuperSpine, show BGP session. Show BGP L2 EVPN summary. Show IP routes VIF tenant 1. Take a look. The EVPN neighborship with my super spine. Show IP BGP summary. We have underlay and overlay neighborship with my super spine. Go to topology, check the configuration. In here, we have a super spine in ISN and a shared border DC1, DC2. Shared border fabric is connecting to my super spine route server. It has two neighbors. One is the IPv4 BGP neighbor, and one is over the loopbacks between loopbacks for overlay EVPN BGP neighbor. All right, so we have it all down that for the multi-size. The topology is built. I have shared border DC1, DC2, and they are connecting to my super spine route server. They will talk about that. So if you don't see it, try to remove it from MSD and add your fabrics again, okay? Now, we have zero network, zero VIF. We have to do something about it. We need to add it for VIF. Create a VIF, we'll call it tenant1. Propose a VLAN. Let's say create. I'll create a network. Give it a gateway. I'm sure we can serve for the green tenants, tenant 1, and that's multi-site. And we have to create the external L3 connecting to my shared border. Let's create that one. So all we have to do is to attach this VIF to all the switches. And it's gonna push all the commands. Let's close it. Deploy network. We say tenant 1 net 1. Save it. And we want to attach to everywhere. According to the map, the diagram, we could tell which ports to the ports we wanted to assign this tenant 1 net 1. Let's sort it out. DC1, leaf 1, network name, why it's not changed? That's okay. We will, sometimes it's glitch. We want to create tenant 1 net 1. The name doesn't change. We'll have to create again. Propose a VLAN. Okay, that's multi-attach. All the switches. Now it changed. Sort about the switch name. DC1 lead 1, I believe that's my port Ethernet 1/2, and it should be an exit port already from previous lab. You have to do it your own, and under my DC1 leave 2 is 1/3, and DC1 DC2 DC2 leaf 1. That would be my Ethernet 1/2. So save. Next. I'll push all the commands. Okay, configure pushed. Now let's go to my topology. Now I have one network, one VF. They all, they'll be pushed to the leaf switches, spine, and super share the borders. All right. So what we can do, can go to individual sub child fabric and do a recalculate, see if we need anything be pushed to the leaf switches. We assume there will be no. Okay, good. And that configuration is down. Added the share border to MSD is a part of a multi-site domain now. And next, our job is to create this external fabric, AXT-L3, external L3, AS number 65333. And we'll create the BGP neighbor with my shared border, and we'll inject a route 192.168.111.0 to my tenant 1, and I'll make sure it can be pinging DC1 host and DC2 host. All right, so we'll use the VRF Lite to create this connection. All right, go back to my next dashboard fabric controller. Here we're gonna create a new fabric. The new fabric name as external L3 fabric, and it would be a external connectivity network, and it says the fabric for core and edge router deployment mixed of Nexus or non-Nexus devices. So you can have your CSR router, ASR router here. AS number 65333. Uncheck battery management mode because we'll be configuring the devices in this fabric. Go to Advanced Resources Backup, Bootstrap for monitor that all be default. Save that, and go into this fabric. Click switches. We'll add my switches into it. Discover. Add a switch. Also simulating this device as a 9300. No worry about it. You can use ASR, CSR, whatever model you want, as long as supported. All right, the switch is added. First thing we'll do is to set a role. A role would be edge router. Click edge router. and we'll find is, well, give it deploy. All right, close that. Nothing to deploy. Go to share border. Close this. Go to MSD. Want to go to the VIF. Double click. VIF attachment. We want to go to the share border. Click edit. So this way we wanted to attach. Okay. It's already attached. Go to VIF in the share border fabric. Double click, VIF attach. In the extend, we wanted to use VIF Lite. Maybe I need to go to my switch and do a recalculate. Shared border. Just 19 lines pending. All right, so let's deploy this first. So it's aware of the link to my L3 external site. Okay, so let's see if we can see the VF extension. Attach, extend VF Lite. Now it shows up. Let's edit this. The IP already designed. Neighbor is .6, itself is .5, and we use .1Q VLAN 2. Okay, save that. Attach extension. Use VF Lite. Save. And we'll deploy. All right, after that, close this and go to interface. I'll go to links. We can see the link is present between the border and an external router, okay? For that, we don't have IP for the external L3 site. We can deploy, showing pending already. And this is gonna configure a sub interface, a BGP, and a VIF. All right, deploy is complete. We'll go to external routers, show around. This is the main interface, .2. We have an IP assigned, show IP, show BGP session, VF tenant 1. The tenant 1 got permissions to the external router as well. All right, show IP BGP summary, VF tenant 1, the IP route, VF tenant 1. Here we're seeing the routes. show run BGP. There you go. If I go to the DC1 leaf and we track this route, I don't see we even have a route. Okay, we don't have a route to this subnet 111. Okay, why is that? If I go to action route, I don't have a route advertised into the tenant 1 BGP. That's why. So what I do in the external L3 fabric, we'll add a policy. So add a policy. The policy is going to provision to my external router. And template is called BGP VF network. So this is going to inject advertise the router 65.333 tenant 1 VF 192.168.111.0/24. That's the route we want to advertise into the BGP, into the fabric, in the tenant 1. Okay. And go to the interface. I know my server, tenant 1 server external, is connecting to the ports right here. The ports 1/2. So we need to make a default gateway port, right? So 1/2 port, we're going to edit a little bit. And for sure, it would be an interface routed host. So it's gonna be my tenant 1 VF, and it's gonna be on my gateway. /24, and that'll be it. Save this port config and deploy. Together with my policy, they will be deployed for the configs. This interface to be configured. I'll do one more deploy. All right, deployed. Show run interface E12. It becomes a gateway interface. And we want to close that. We want to deploy that policy. Policy will deploy. We just advertise a route to BGP. Okay, that's deployed. Show run BGP again. 192.168.111.0. Go to leave one, see if I have that route. Route is showing up here. Okay, the route is there, and I got a default route to the share border also. So from this route injected through tenant 1 to my tenant 1 host, this all here, and go to my share border, logging again, show around BGP, have BGP, tenant 1, automatic advertise default route. There you go. The external router show IP BGP VF tenant 1. I should have the routes. So logging to the T1 server external. Let's ping the gateway. The other network gateway is good. And if that's pingable, I should be able to ping the host in DC1 100. Only the other leaf. That's good. on the other DC, DC2, 200. Ping is okay. So that's everything about my share border. The entire topology is just showing like this. DC1, DC2, right? DC1, DC2, and then my ISN super spine route server, share border, fabric. They are in my multi-site domain fabric. And I have external L3, external fabric, the routes between. The fabrics will be shared through the share border fabric. And share border is your go-to point to the external fabric or go to internet. All right. You can build 2 share border router and using a VPC for redundancy. This is the whole idea in my lab. If you have a question, leave a comment below. I'll see you next time. Thank you.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.